Please go ahead, sir. We are live now.
Good afternoon to all of you and welcome you all in today's webinar on coal gasification in India. We are extremely thankful to all the panelists for accepting our request to join today's webinar. We are sure many important points and issues will be addressed in coming to us. We are also thankful to all the participants who are listening to us right now. With this word, I would request Mr. U. Kumarji to address and moderate the session. Over to you, Kumar sir. Thank you.
Thank you, Mr. Sharma, and good afternoon, all of you. I must start with a compliment to ASSOCHAM for selecting such a topical subject for the discussions today. And I see from the list of speakers that same amount of care has been taken in selecting the speakers as well. They're all they're all top notch in their fields. And I am very certain that today's proceedings would be worth remembering all our time. Mr. Sharma, Mr. Jaidev Sharma and Mr. Amit Sharma, they have been really the broad shoulders. They are carrying the ASSOCHAM, the message of the ASSOCHAM. And I really compliment them for doing such an excellent work. Between two of them, the pot has been kept boiling all the time. And this is the most important, that they have selected such subjects which are very topical, as if they are guiding the industry in what to talk or what to do. So thank you very much, Mr. Sharma, Mr. Jaidev Sharma, Mr. Amit Sharma, for giving me this opportunity. Now see, talking of coal, I mean, it has become a very cold subject for the last 30 years. The entire world is after coal. The entire world is forecasting when coal will die. Unfortunately, coal is such a feature that is refusing to die. And despite all the promises that are being made by different countries for no coal in certain years, I think probably leaving aside Western Europe, nobody is very serious about the timeline that they have been projecting. We look at it, China, USA, Vietnam, all of them are increasing the coal production, and so are we. So, I mean, even the forecast is there that till 2050, coal will continue to remain very important for India. And it's understandable because you have no choice. We are going ahead very admirably well on renewables. It's an excellent job being done. Already achieved about close to 120 gigawatts. And the Honorable Prime Minister has given a call that we hit 500 gigawatts by 2030. But all said and done, unless the storage arrangements, economic storage arrangements are evolved for renewables, coal will continue to be called upon to meet the base load. And base load alone is about 150 gigawatts. So probably coal is going nowhere, at least in our lifetime, and within maybe next 3 to 4 decades. But then, having accepted that yes, we can't do without coal because we don't have anything else, we have to see as to how the pollution load, the adverse impact of coal can be reduced on the environment. And a very effective step had been taken way back in 97, that the government MOEF had come with a mandate that all pithead power stations, 1,000 kilometers and more from the pitheads, they have to use only coal having 34% ash maximum. This distance was cut down 750 and then to 500, and it appeared that gradually we are moving towards the ultimate objective of asking all the power stations, irrespective of wherever they are located, that only washed coal should be used. But I mean, to my mind, it's unfortunate. I don't question the wisdom of the people who have done it. They must have something, they must have a long-term view But I do hope that having the mandate for using wash coal having been withdrawn, the industry themselves, both coal and power industry, coal producers and the coal users, will see the wisdom in washing the coal. This is advantages from all angles. And they, irrespective of the government mandate, we should seriously look at it. So that is one. And probably some other methods will have to be brought in, like say the linking the power station performance with the specific coal consumption. And those who are consuming more, probably they will be lower in the priority for supply of coal. Probably those things will have to be thought of. But I do appreciate that otherwise the country is moving in that direction. I think all the power stations coming in the future, 500 gigawatt and 500 megawatt and above, will be using only supercritical and ultra supercritical technologies. That should make a lot of difference. And a lot of power stations which have done their life to be 25 to 30 years, they are being phased out. And in their place, the new stations will come up. So hopefully, we'll discharge our obligation as a responsible citizen, country citizen, for ensuring that despite our dependence on coal, and unfortunately we have nothing else, we are as conscious about the need for taking care of environment. So this is one subject which leads effectively in that direction. I think all the qualities of coal, coal is a very sort of it can be used for many purposes. We have been using coal for power generation. We've been using coal as a fuel, but it can as well be used as a feedstock. And probably time will come when they are supposed to kill the coal for power. The time will come for coal to come more effectively and to produce better value products like chemicals, fertilizers, methanol, things like that. In that direction, work has started. And Coal India itself is setting up a mammoth methanol plant at Danpani. I am not very sure whether it will be economical. This is a step in the right direction, and that will show the world the seriousness of the situation. About coal gasification, the Prime Minister has set a target of 100 million tons by 2030. The Honorable Minister for Coal has confirmed it. I'm told it will take about 4 lakh crores of investment, and it will take about 4 years' time. But it has been learned that it's being started very carefully. Like when you initially start with the high grade coal, and then gradually we gather experience, we'll come to the lower grades. We'll be hearing from Mr. Tiwari. I mean, he's a pioneer in coal gasification. The plant that they have set up at Angul, I think it's anybody's envy. Such difficult circumstances, no good coal being available in the country or to them, and they are yet making such an excellent job out of it. Mr. Naveen Jindal, the young entrepreneur, it is his vision. But what has been transported, the vision has been translated into reality by people like Mr. Tiwari. And we are very fortunate that he is with us. And I'll request Mr. Tiwari to call upon him to give his learned views on the subject and share his opinion and share his experience with us. We are little hard pressed for time, but we are sure that we'll be able to hear Mr. Tiwari right through. I've heard him earlier, and I'm assuring you it will be very, very interesting. Thank you very much. Shri Tiwari.
Thank you, sir. I think you have briefed everything, and The topic is opportunities and challenges in the coal gasification in India. I will start from the two things. I think my father used to tell in 1976 when I was in high school, if you don't start in time, you will miss your train. You may get a better train, but you will not get that train at that time. So for coal gasification, this is very true. The second thing, I attended a seminar in 2000. It was held at Hyatt, Delhi, when they were doing this for bringing the natural gas from Bengal. It was done by the British gases. And that time I put a question to all the senior people, which was attended, some secretaries, Mr. Suvir Ra, that we don't have the natural gas. Whether we'll be conducting similar seminar after 10 years for the coal. At that time, people did not look into that, and it has happened. After 10 years, 2010 onwards, Tata Sunil Kumar has started his coal gasification seminar every year. Coal gasification in India is not new things. Coal gasification in India was from 1944 when FACT was doing, then Sindri FCI has done, then effort was made in Ramagundam. In 78, 80s, we had 3 plants. Out of that, 2 were started. Then again, it was gone down. And again, 2004 onwards, Mr. Jindal has started and we have done it. So opportunity is unlimited. Only thing we miss the time. We should have done this at least 4 decades ago, but never the late. Now the government is focusing on that, and as Mr. Kumar told, it's a very ambitious plan to have the 100 million coal gasification by 2030. So we have a lot of the opportunities because still many countries who are forcing for that environment reasons. Okay, environment is a concern, but still India is not, if you go to the per capita emission from our country is less than many developed countries. And they will always try to push that. It doesn't get succeeded. So that will be a tough task. And coal gasification, we have started with the fixed bed gasifiers. We don't say that this is the best technology, but all the 3 types of technology will have their own problems. And we have to move along with that and we have to make the changes. We cannot say that initially in the first go itself, it will be very successful or it will be economical. As Mr. Kumar told that we are putting a methanol plant in Dankuni, and economically whether it will be viable or not. So definitely it is a challenge. People must be ready to pay high for that if you want to become the self-sufficient in energy in India itself. And so all 3 types of technologies are there. Still, government is pushing for indigenous technology. Indigenous technology are going to take time. We must start with the available technology and we have to modify them, make our own technology as China has done. If we think that we'll be starting our own technology from the first plant itself, it will be very difficult and it will be tough time. The product methanol is being already government is asking to go for methanol, and methanol plants, if you look in the world-wise, 5,000 TPD plants are there world-wise. Indonesia is making a 9,000 TPD plant based on the coal. So the huge capacity they are building up, and that is more viable compared to us. And in the world-wise, methanol capacity utilization is only 80%. The 50% of the methanol is produced in China, and 50% produced other than China is also consumed, 50% of that in China only. So initially it will be challenge. The major challenges today is there. Who is going to invest? Because there is a huge amount of investment is required. And without proper support, proper policy, nobody is going to invest in that. As a JSPL, we had been arguing for the last 7 years with various forums that give us coal. We have a plant. Any new plant will take 10 years to come. We did not succeed. Finally, now we are allotted the mines, but operation of mines and other things are going to take time. And if you look at today, also we are struggling for the coal because power sectors are being given the preferences, and coal is really not available for the coal gasification. We are the single coal gasification plant. Today also we are struggling till we operate our mines. That point of view, still government has to support the plants, and then only these plants are going to survive. I'm not talking much about the technology. Any coal can be gasified. There is no problem in gasifying any coal, any part of the India, whether it's a high ash, low ash. Only thing we have to design the plant according to that. And it must start what we want to produce. What is our end product. Based on that, only technology selection has to be done. We cannot say that this technology is best and that technology is bad. It will depend upon our end product, which end product we are looking for. So for that, we have to calculate and go for that particular technologies. So opportunity wise, okay, we can make methanol. Then again, we have to think of using methanol for making other products. From methanol, we can make various products. We can make olefins, we can make other products. It can be used in the fuel. So all those things also we have to think of. We don't think we only end up only making methanol or mixing in petrol. Then again, it will be a big problem for that. We'll not be able to go ahead with the technology, and initial challenges, initial cost must be supported by government, and we have to see that people must be ready to pay, and we have to utilize the chemical energy of the coal rather utilizing the thermal energy we are using today. Definitely the coal, if you go for the IGCC, the cost will be slightly higher than what the today super thermal plants are producing. So that will be a challenge because people have to pay extra for that cost. Then only will be able to. The other challenge is capturing the CO2. How to utilize the CO2? We are talking that it can be utilized for making methanol or making fertilizer, but the challenge is where from the hydrogen will come. That extra hydrogen, where from it is going to come? If you are talking the green hydrogen, other things, only water is the source, and that is still not as cheap that you can get that much hydrogen. If you can get the hydrogen, then converting CO2 into urea or methanol is easier. That is going to take time, and people are working, industries are working. That will take some time. Other things I think is the major challenges are the investment. Who is going to make the investment? Because this question also I think many times I asked. The policy is made by the government. Government has to make sure that this policy continues for the 20-30 years. In India, we have some typical problem, and the government changes, the policy changes. And if the tomorrow policy changes, again, the people who are going to make investment, that will become a threat to them. That's why no private players are interested in putting this coal gasification plants. So I think it's this much from my side, sir. If you need any question, then particularly we can ask it. You are not audible, sir. You are not audible. Kumar sir.
Can you hear me?
Yeah, now you are audible, sir.
So we discussed it earlier before you came. We'll finish all the presentations, only 4 of them are there. And then we'll have sufficient time for questions and answers.
Yeah, yes. Okay, sir.
So now I call upon Mr. Sumir Kulkarni, Strategic Planning Head, Thermex. I mean, when you talk of Thermex always leads the way. Thermex is far ahead of our thinkers in the planning for government. And whatever they take up, that becomes the call of the day for others to follow. So, Mr. Kulkarni, we cordially invite you to share your thoughts with us. Thank you.
Thank you. Thank you, sir. Can I have the share rights, please?
Yes.
Can I have the presentation share rights? I'm not able to share the presentation.
Yes, sir. Now you can share, sir.
Okay, okay.
Sir, I think sharing option is not active.
Not active.
Yes,
It's visible.
yes, sir.
Your slides are coming.
But
Is
for
it visible now?
Yes, sir. Like say, Thermex experience on coal gasification.
Yeah. Okay. Thank you. Thank you, Kumar sir, for the kind words for Thermax, as well as thank you, Asochem, for giving us this opportunity to make this presentation. And I will just quickly run through the slides and and then we can have a question answer session at the end. So a small one slide on Thermax. Say Thermax is providing utility and solutions in power, heating, cooling, water, and chemicals to the industry. Basically, we are working in the commercial and industrial sector. And also we are treating the air, wastewater, hazardous, and waste to energy solutions. We are a $800 million company headquartered in Pune, and our presence is there in 27 countries with the installations spanning over about 88 countries. So, as far as the fluidized bed thing, because I will be more primarily talking on the fluidized bed. So, we have a lot of 3 decades of experience in the fluidized bed combustion technologies, where I think we have provided solutions to very, very difficult fuels like spent wash coming from the distillery waste, or a lot of biomass, about 200 different types of biomasses. And we have built very large boilers in the bubbling bed, circulating bed regions. So all this experience we used when we started our journey on the gasification side. I think I was just going through the flyer of this webinar, and I mean it's so well articulated that what is the necessity of coal gasification, why you need coal gasification, and that is so. At least it has saved my 2-3 slides. But if I have to give some numbers, we have a large resources of coal, out of which almost 50% is high ash content. And we are, I mean, as far as the coal use is concerned, I think in next about 8 to 10 years, we will be doubling our coal uses. So taking these points, basically we have a very high high reserves of high ash coal, and so that we should have a technology which in future at least can use the high ash coal is the basic premise we started our journey on the coal gasification. So I will just take one slide for the on the different types of the gasifications. We started our journey in 2011 with looking at different gasification technologies and what it will best fit for India. There are 3 technologies: fluidized bed, entrant flow, and moving bed. And as Mr. Tiwari also mentioned, there is not a single technology which is best. All technology has its own place in this gasification domain. I cannot say fluidized bed is better or than interplane, but they may have certain advantages and disadvantages when it comes to application, or when it comes to gasifying different types of coals and producing the required quality of the syngas. The technologies may have certain advantage and disadvantages. So look at the moving bed. It needs a specific feedstock which is less tolerant to the fuel quality. It cannot accept fines. In a moving bed, there is a high tar yield or the high content of tar in the gas, and requiring the more downstream cleaning equipment, and difficult when we increase the ash percentage in the coal. Similarly, the entrant bed, you require a pulverized coal. For typically Indian coal have more than 1300 degrees ash fusion temperature, and so you have to use a lot of flux agents to reduce the AFT, and it is at 35 to 45% ash. The slag removal becomes challenging, and so it is more suitable for the low ash and high carbon fuels for large capacities. These 2 technologies will provide or will generate syngas which is much higher in calorific value as compared to the fluidized bed. Where when it comes to the fluidized bed gasifier, it doesn't require elaborate pulverization mechanisms for the feeding. It can accept 0 to 6 mm, so fines also can be accepted. It can work with medium reactive fuels. It can accept the high ash content coal. Its operating temperature is lower, between 950 to 1000 degrees centigrade, well below the ash fusion temperature. So the reliability and then the availability part is much better. Then it can have a better heat recovery and integration, because because it is not going into the slag zone, so we can integrate the heat recovery sections in a much better way. And at that temperature of operation, the no heavy tars are there, and with a simple gas treatment, it can work. So we said we will work on the, and like other Indian institutes like SIMFAR as well as BHEL, we started our journey with the fluidized bed, the technology, and worked on this particular technology. And fluidized bed has different regimes, bubbling. I will not go into that details, but I will take you through the journey, how we started our development a decade back with working in a turbulent bed mode, and then looking for a high pressure design up to 30 bar. But we faced challenges. We had a small combustor or a small gasifier. It had a lot of slugging flow wall effects. The carbon conversion was low. So we decided since there was a high coal loading area per square meter of the bed, which was exceeding 4,000, we found that so much of coal in such a small bed, it cannot accept. So we went for in our next generation fluidized bed gasifiers. We reduced the pressure, and we said we'll have to operate at between 6 bar or less than 6 bar. So we built another two gasifier prototypes with a bubbling bed, and but one at atmospheric, one at the pressurized, and all of them had a provision to work under air blown mode or the gasification or the oxy-blown mode. And with these two new prototypes, we overcome many of the challenges. We had improved the carbon conversion, and all the diameter also became much bigger. So then we went into the another model where I think we went to the much larger diameter and optimize all the parameters for this gasifier. And this is the gasifier which is working for the coal to methanol plant, which recently we have commissioned and successfully generated methanol. So this project was in collaboration with IIT Delhi and funded by DST, and Niti Aayog was also very much involved into this project. So this typically we have also tested now the 46% ash in this particular model, and we are operating it under oxy-blown conditions, and we have connected with all the gasifier with the downstream equipments, gas cleanup, as well as the methanol reactor. And since February, I mean last 2-3 months, we are conducting a lot of trials on this. So basically the gasifier is only the one island, and when we want to use it for other applications like methanol production or ethanol or hydrogen production or other chemicals, it has to undergo through a different gas cleaning system, because it naturally has a lot of impurities in terms of tars, ammonia, COS, or the mercury, or H2S, or the CO2, which needs to be removed, because these are sort of a toxic nature for the downstream equipment. We have understood all these things, and now the plant that we are built here is now stabilized, which was we are able to generate methanol from the coal, and a lot of optimization trials are going on. Before we constructed this plant, we had done a lot of work on this in terms of the CFD, as well as the how, because in a fluidized bed, the residence time is very, very important. And to arrive at a particular residence time, what should be the bed height, what should be this thing. We carried out radioactive particle studies along with BRC and IIT Delhi, and arrived at the optimum parameters which are there for the bed. So these are some of the pictures of this coal to methanol plant. These are some of the pictures of the test conditions and the quality of the methanol that is getting produced. I will just so we are getting a good hydrogen to CO ratio, as well as the plant is operating very stably, keep maintaining the temperature parameters. And as you see here, we are using the 46% ash coal in this unit. Coming to some commercial aspects, since now the pilot studies are over, and I mean, we are again not putting the trials off. We will be conducting more trials with the different types of coals from different mines. But if you look at the commercial part of this, today, I mean, I'm talking in terms of the methanol only right now, because commercially we have seen that the methanol price is very globally, I mean, they are highly volatile. And today the methanol is available at 32 rupees a liter. And if you look at the cost breakdown structure, normally the OPEX part is about 70% and the CAPEX part is about 30%. And even if in the OPEX, if you look at about 70 to 75% of the cost comes from the coal and the other utilities like oxygen, electricity, water, and other things. So if you put the mathematics, we should be the operating cost or the utility and the coal cost should be restricted within 15 to 17 rupees if these methanol plants are to be made commercially available. And now, if you work backward, okay, then if you want to contain this cost within 15 to 17 rupees, what you should do is that, okay, the city, these plants should be at the mine mouth, because it should avoid the transportation cost of the coal. The coal should be available at a reasonable rate. And this high ash coal, I mean, of course, the rates of the coal will be lower compared to the good coal. And the utilities, because the electricity cost, if you purchase it from the grid, it is at a much higher rate. So if these plants are supported with the utilities like cogeneration facilities within the plant, I think these mathematics of getting the operating cost between 15 to 17 rupees will work out. Now what next? I think we have done this R&D phase, we have demonstrated the plant, and so the R&D part of the whole thing of this indigenous technology is over here now, and we have all the technology blocks which are ready now. These are the technology blocks which are ready now. If you want to take this gold gasification to the next level of producing at a commercial level, the hydrogen or the DME or the ethanol, methanol, syngas, or the other chemicals, what is required? So I will come to this point. Okay, I mean, commercially, when all these tenders are which are coming out, these are in the range of 1500. I'm talking in terms of the methanol plant, about 1500 to 2000 TPD plant. So can we go directly from here to the commercial plant, or what are the risks, or if there are any technical risks, do you need to construct a plant which is of the intermediate scale? Is something which we are discussing. We are discussing with the Ministry of Coal, so that the financial outlay for such plant is also can be minimum. Some financial support is required, because at this scale, whatever scale that we will be doing, it may not be commercially viable plant. So some financial support will be required, and it will need public-private partnerships in terms of taking it. So when we are wondering, okay, I mean, what should be the plant capacity, we can easily scale the R&D at 25 to about 100 scale, make this plant at about 25 to 100 TPD, and then you don't need any a project or any financially supported plant. Then we can go directly to the 1500 TPD level. So this can be some sort of a lighthouse project which can take the R&D, the indigenous development, to the commercial level with one-step lighthouse project. Of course, the CO2 management is a very important point, as also mentioned by Tiwari ji. And I think we are working on this CO2 management. I mean, how do you convert? There are challenges. The availability of the green hydrogen at a lower cost, or we are also thinking whether it can be injected back into the mines to generate more CBM. So all these things are going on actually. So to cut short the story now, I'm just making 4 points in this particular presentation, that fluidized bed technology is well established by R&D, Indian R&D centers. It will be Thermax or Simfer or BHEL. This is the when it comes to the high ash coal, it is the most apt technology. We need a first lighthouse project to take this R&D to the commercial level, intermediate step this thing. The coal cost and then the other look at the commercial viability. We need some support from the in terms of the plant location, the policies and other things. And we also need to build a appropriate ecosystem for end-to-end solutions within the country in terms of the air separation units, compressors, ash filters. There are many components which we have proven it at the pilot scale, but when it goes to the larger scale, we need to have that ecosystem created, vendors created, sub-vendors created for this thing. So if you look at the coal gasification, I mean, this is the total canvas of the coal gasification. It can go to the power generation, improved efficiency, thereby reducing so through the IGCC cycle is one route. You can generate chemicals, fuels from this thing, so that the carbon is getting fixed when you generate the chemicals. When it goes to the fuel, it becomes the second use of the carbon. So there is a carbon decarbonation which is happening. Other thing is there are import substitutes, because there are a lot of industries which use natural gas or furnace oil for the for heating purpose. Now this coal gas can replace such plants or use of FO and natural gas and for this purpose. Similarly, there are biomass gasification also should not be missed out while we talk about the coal gasification, because it generates it's a carbon neutral technology, and there is a lot of work being done in India for the biomass gasification also. With this, I think I will stop my presentation here, and I would like to take the questions when during the last session. Thank you so much. Sir, you are on mute.
Sorry, we have already overshot the time allotted to us. We are only 15 minutes we have in hand, and 2 speakers are yet to cover. So one thing, I mean, Mr. Sharma, the entire overshooting is not our fault, because you started late. So that much I'll take, that much extra time I'll take. But I'll request the speakers to kindly conclude their presentation within about 10 minutes time. Thank you. And now I call upon Mr. Rahul George, he's the country head of CGS group, case group. I'd request him to kindly speak about the case group, because I'm not aware of it. Many of participants also may not be aware. And then come to your subject. Mr. George.
Yeah, hi, good afternoon. Thank you very much for this lovely introduction. I'm really grateful for ASSOCHAM for letting us be a part of this prestigious event. See, our main reason for being part of this conference is to stress upon the usage of coal gasification as a thermal fuel for the industrial energy demands. We have seen in the past, like our journey of coal gasification of more than 15 years in India. Majorly, impetus has been given to coal gasification for technologies which are based on coal to liquid conversion or synthetic natural gas, etc. Not much has been done in the area where coal gasification is set up as a fuel to cater to the industry's thermal demand, which is still reeling under the pressure of using high-cost fuels such as HFO, LNG, natural gas, LDO, etc. Today, this field of gasification has come a long way with technologies which ensure negligible pollution impact on our environment. I will be sharing a few of such slides available today with us for a better understanding. I'll just. Amitji, I'm not able to share my slides.
So you are the presenter right now.
I am not able to. It's asking me to quit the application and then re-log in again. Can some presenter take over and then I can join back? I think I'll have to quit the slide. Is that okay, Kumar sir?
Would Mr. Chatterjee like to take over? Mr. Chatterjee? Mr. Saurabh Chatterjee? You had told me that Mr. Chatterjee has come.
Mr. Chatterjee is there. I think he's on mute. Mr. Chatterjee, we can't hear you. If you're good with the presentation, then I will quit this and rejoin again and then start my presentation, if that's okay with you.
Mr. Chatterjee, sir, you are on. Are you audible, sir?
Yeah, now. Are you speaking? Yes, can you hear me? Mr. Chatterjee? Yes, can you hear me? Have you unmuted yourself? I have unmuted. Hello. Yeah, Mr. Chatterjee, we can see you.
Am I audible now?
Yeah, kindly speak. Kindly unmute yourself. Go ahead. Mr. Chatterjee belongs to, Dastur, the leading industrial research organization in the country. And we'd love to hear him, because I'm sure they will have something to present, which will be highly interesting. Mr. Chatterjee.
Some technical glitch.
Are you starting, Mr. Chatterjee? Kalyan Sahib, good afternoon.
Afternoon, sir. Some
Right
technical
in the
glitch, perhaps.
screen by your presence.
Sir.
And you should smile. Such a warm smile.
Sir, thank you. I think Mr. Chatterjee is having some technical glitches. We could see him, but yeah. Can you hear us, Mr. Chatterjee?
I can hear everyone very well, but I'm not sure if anyone can hear me.
I think you need to come closer to the microphone, please.
Am I audible now?
Yeah.
Yes. Go ahead.
Okay. Thank you so much. Mr. Sharma, I would like to share some slides, please. If you could, yeah, I have the permission. Thank you.
Sure, sir. Nobji?
Yeah, I have the permission. Just give me a minute.
Yeah.
Is my screen visible?
Yes, that's right.
Okay. So thank you, Mr. Kumar and SHM for the opportunity to speak on this very relevant topic of coal gasification and how it can contribute to energy security in India, especially given the context of high crude oil prices that is prevailing today. What I wanted to talk about today is what are the issues for coal gas, for issues to be addressed for coal gasification to really take off, and how at Dastur we kind of look at the entire value chain of the coal gasification, right from feedstock, technology, markets, products, and how these need to be addressed to have robust and commercially competitive coal gasification projects. So just at the start, I would like to just spend a couple of minutes talking about Dastur. So Dastur Energy is the affiliate of the Dastur group of companies, which really works in the clean energy space. And our focus really is on industrial decarbonization, cleaner energy transition for different industries where the use of fossil fuel or cannot be really replaced, or electrification is very difficult. And we work in the areas of technology licensing, your areas of consulting in terms of consulting clients on products, business models, techno-economics, and engineering, clean energy projects. And our value proposition kind of translates into designing clean energy projects based on gasification, new new and clean energy carriers like methanol, hydrogen, as well as this entire piece about carbon engineering. How do you do gasification?
Forgive me, Mr. Chatterjee. I think the schools activities are very well known in the country. They are leading. I'll request you to kindly come to the subject.
Right. So, so the carbon engineering is another area we work on. So these are some of the projects we have done. I don't want to spend too much time on it. Going ahead, so what are the key enablers we think are required, or what are the key aspects to be addressed for coal gasification really to be successful in India? One is, what is the technology that is most appropriate or most suited for Indian coals? What are the challenges that need to be overcome with respect to coal gasification, and not only with the gasifier island but across the value chain? What are the flexibilities and flexibilities that you should have in terms of different products put in your portfolio that to really have a gasifier project which can react to different market scenarios. So I'll try to dwell on each of these points. So on the technology front, if you look at gasification technology, this is not a new technology. The earliest gasifiers have come up in South Africa in the 50s, in China in the 70s. But what really is the challenge for India is, how do we handle high ash coals with 40-45% ash content on the higher side, and the concomitant issues of the higher throughput of feedstock. How do you handle that? And so, given these challenges, and Mr. Kulkarni has spoken at length on the different technologies. So, given these challenges, the technology which seems most suited for Indian coals is the fluidized based gasification technology. The key advantages is that it can accept high ash coals and can work on fines. So you don't need to put another power plant for handling the fine or for consuming the coal fines. Non-slagging operations, and the high reactivity of Indian coals, which favors the gasification process. Going ahead, if we look at the challenges across the value chain of gasification on the gasification island I spoke about, if you look at the next challenge being the gas cleaning and conditioning. So these are the challenges with contaminants in the raw syngas, and the need of superheated steam for your gas conditioning and cleaning plant. So here, what works is, or what the advantages that are there in the approach is to have a water gas and carbon capture island where the acid gas like SOx and CO2 can be removed. And also there is the steam that is generated through the gasifier operations that can be used for the steam duty of the your gas conditioning island. And so you have better heat integration of the system, and the H2S that is there, that can also be used to generate sulfur or sulfuric acid. The next challenge, or the next sequence, is really the carbon management. So you do the gasification. What do you do with the CO2 that is generated, that is captured through the gas cleaning island? So this is a significant challenge for India, because the utilization of CO2 is going to be limited. We have to look at options for sequestration and EOR. So the mapping of and characterization of pore space is very limited in India, and there is no pilot or demo scale project yet which has been established in India. So what is really necessary is to establish some of the frameworks, the MVA framework for risk management, adopt some of the tools and technologies for space mapping and characterization, and really to conceptualize a pilot or a demo scale project to prove that sequestration or EOR of CO2 is possible in India. The next part is to do with CO2 utilization. So this, I mean, although this will contribute a small quantity to the, compared to the CO2 volumes that you have to deal with, but there are certain technologies which look promising in terms of conversion of CO2 to products. CO2 to methanol is certainly, one opportune area, and these are some of the technologies are nearing commercial deployment. And one of the speakers also spoke about when you are wanting to make methanol, what the issue is, how do you get hydrogen or clean hydrogen to make the methanol with the CO2. So the project, the coal gasification project, can be configured in such a way that you have in situ production of hydrogen from the syngas, so you have a low availability of hydrogen as well as a low cost source of hydrogen, which can be combined with the CO2 to make methanol. Going ahead, the next point I wanted to speak about is really the product portfolio and how do you design a product portfolio which is robust and gives you the flexibility to react to different market scenarios. So just making one product like methanol, which is a low value product and has and is the price is extremely volatile, that is something that brings a lot of risks to the project. So based on our experience of designing different gasification projects for clients, we believe that it's necessary to look at value-added products beyond methanol. Some of these products could be MEG, could be acetic acid, and the way you really construct your product portfolio is have components which have not very high correlation, so that based on the market dynamics, you also configure your project in such a way that you can change, calibrate your production of different products in reaction to the market dynamics. And apart from having market-facing products like a MEG or acetic acid, what can also lend a lot of stability to the financials of the project is to also have utility-like products like hydrogen or clean power, which also lends stability. So on one hand, you'll have stable cash flows coming from selling hydrogen or clean power, and on top of that, so that will contribute a part of the cash flows, and on top of that, you will have market-facing attractive products like MEG and acetic acid. And if we also look at let's say gasification projects around the world, some of the successful projects like your Sasol in South Africa or Synfuels project in US, they all have multi-product portfolios from their gasification projects. So this is a schematic of a candidate project, as I spoke about. So this is based on some of the work we have done. So this project involves gasification, and we have considered comparatively higher grade coal. So this is based on your G4 coal, and that the syngas produced is treated through your water gas shift and acid gas removal your unit, and then the syngas, treated syngas, is used for methanol production and hydrogen. The hydrogen is thereafter used for MEG production and generating some clean power, and the methanol is entirely consumed in making, or most of the methanol is consumed in making acetic acid and MEG. So if we look at the project financials with a multi-product portfolio of attractive products, which and these products also have significant import component in the Indian market. So this makes for attractive financials. Although your gasification projects are associated with very high upfront capex, but even then you can see that and these we have considered market prices. This kind of project can generate healthy return on investment northwards of 20%.
Thank you, Mr. Chatterjee. So,
I had not finished. Okay, I just another point I wanted to make is that apart from your different your chemicals, the hydrogen, your coal gasification can also drive the hydrogen economy in India, because we talk about green hydrogen from electrolyzers, but at the current cost structure, it's not really sustainable. So even a coal-based gasification model where the CO2, where the main product is hydrogen, that is also very sustainable. It seems to be an attractive proposition.
Okay.
Thank you. I think in the interest
Thank
of
you.
time,
Thank you.
we conclude.
Thank you, Mr. Chatterjee. So, Mr. Rahul, Mr. George, are you ready? As you know, we have already consumed our time. Mr. George?
I'm very much here, sir. Just a second. Can I get the rights for sharing, please?
Yes.
Yeah, I will try to. Yeah, do you have the rights? No?
Not yet, not yet. Okay, I have. Thank you. Can you see my screen, sir?
Yeah.
Yes, sir. Please go ahead.
Okay. I am sorry for that technical glitch, Kumar Saab. I don't know, there was some issue. Anyways, basically, CASE is an organization. We have been working in the industry for coal gasification for almost 15, 17 years in India. We introduced hot gas to India in 2007. And with that, we started doing pyrolysis, fixed bed gasification. Then we tried to, get circulating fluidized bed technology into India, and then further we put our feet into in-train flow gasification. So this is just a couple of slides which I would like to share as to what CASE is doing in the gasification industry.
Can you put it in the presentation mode, sir?
Yeah, is it in presentation mode now?
Yeah. Okay, thank you.
Okay, this is the first of our variant. We call it the hot gasifier. This is basically a fixed bed gasification. Basically, you are using 15 to 60 mm of coal size. Then it's a hot gasifier because the temperature of the gas that comes out from the top of the gasifier is over and above 450 degrees. Owing to this property, this is a zero liquid discharge technology, because beyond 350 degrees, the tar or the volatiles in coal, they remain in vapor form, and we take it to the point of combustion and we burn it there. And there is no condensate that comes out from this system. So this is an absolutely zero liquid discharge technology. The capacities of these gasifiers per cell come in 1.2 million ton to 15 million kilocalories to 15.6 million kilocalories. The biggest model that we are doing as per the shell size is around 4.6 meters in diameter. The gas thermal heat values, because of the presence of tar in the gas, may reach greater than 1800 kcal. These are very suitable for secondary steel mills like rolling mills, heat treatment furnaces, strip mills, refractories, etc. We have more than 200 installations of such gasifiers in India. Then we entered into the clean gasification technology. This is again a fixed bed gasifier. In this, we basically reduce the temperature and clean the gas before it is used for utility. Again, a fixed bed gasifier, as I said, lump size used in this is 15 to 60 mm. Gas exit temperatures are less than 45 degrees. Here, what we do is we reduce the temperature and take out all the condensates and the tar that is there in the gas before we give it to the utility point. The tar and the condensates are very professionally managed. All the phenol or the condensate that come out from this gasification technology are recycled back into the gasifier and used as steam as gasifying agent. So there is no disposal of any kind of liquid from this technology as well. That's why we have termed it as a ZLD technology. The capacities again vary from 1.2 to 15.6 million kilocalories per cell. The biggest model would be 4.6 meters diameter. With this technology, we are able to have burner level automation at the topmost. Automation can be achieved with this because of the cleanliness of the gas and because of the temperature of the gas. This is a pyrolysis technology in which the gas that passes through the gasifier also cracks the volatiles of coal into high calorific value CNHM. Because of this, the calorific value of this gas is higher than normal gasification and reaches greater than 1400 kcal per nm3. These are suitable for automatic rolling mills, glass plants, pellet plants, aluminum plants. If any kind of automation is required, these gasifiers are very, very much applicable. Then we have the CFBC gasifier technology. We have a tie-up with a Chinese company called KEDA. They are masters of gasification in China. I would definitely agree 100% with Mr. Tiwari that, rather than doing something indigenous and wasting time a couple of years on this, we already have technologies for this. We should get this technology, Indianize it, and start implementing it without wasting time on these technologies. So we already have a technology for CFBC gasifiers. This gasifies coal fines minus 10 mm. Gas exit temperatures are below 45 degrees. Zero liquid discharge. There is no tar, no condensate that comes out from this technology. Capacities, these are big gasifiers, so the capacities are high, 13 to 78 million kilocalories in single cell. Gas thermal heat values are greater than 1300 kcal per nm3. These are suitable for aluminum calcination, pellet plants, integrated steel plants, basically big applications, whatever it is required, where the gas requirements are very high, thermal demands are high. Then we have the entrained flow gasification technology. This is basically gasifying pulverized coal minus 100 micron. We can use 99.99% oxygen as a gasifying agent for this technology. This is again a zero liquid discharge technology. There is no condensate coming out from this, no condensate and no tar that comes out from this system. These capacities are again large, 25 to 200 million kilocalories per cell. The final gas calorific values can reach up to 2500 kcal because of the oxygen being used as a gasifying agent. There is very negligible nitrogen in this gas. Local high ash coal fines can be gasified, thus making this the most efficient gasification process. Though the capex of this technology may be high, but it has the lowest OPEX for any gasification technology available today in the world. This is our vision of our Honorable Prime Minister to gasify 100 million metric tons of coal. I would say that, with 200 to 250 gasifiers running in India, we are already consuming a lot of coal, and this can definitely, this is a very, very much achievable target, which has been set up by our Honorable Prime Minister, and we should work diligently towards this. Need for gasification, I'll just be very quick. I think I'll skip this because this has already been covered by one of the presenters here. Here I would like to share that all the gasification that we are doing in India, we are working on the Atmanirbhar Bharat movement. Basically, all of fixed bed gasifiers are manufactured 100% in India. All our CFBC gasifiers and our entrained bed gasifiers, 80 to 90% of our project supply is from India. Only critical parts are being imported from China. I would sum up my presentation with this. In case you need to reach out to us, please get back to us. I would like to just say one small little thing, that whatever the energy costs are there, coal gasification will always be 40 to 50% cheaper than any alternate or high cost fuels which are present today in the market. Thank you very much, Kumar Sahab. I would end up my presentation here. You are mute, sir. Cannot hear you.
Said we have covered the presentation. Now we'll take about 5 minutes for questions because we don't have much time. They have left to devote more time to it. If there are any questions, kindly shoot. Not necessary
Sir,
to
I have a few comments, question and comments both.
kindly identify yourself.
Yeah, I'm
Achha, Mr. Tiwari. So
I'm Tiwari, sorry. Because Rahul ji presented all the things. The practical difficulty is what he told in one of the gasifier where you're using 15 to 60 coals. In India, most of the mines are doing surface mining and the fines content is more than 40% by the time it reaches to the customer. So that is the biggest problem for the customer to operate the 50 to 60 gasifiers. We have our producer gas plants and most of the time we suffer because you don't get that size coal. So that is one of the challenges for that type of gasifiers. Regarding Saurabh has told they have made a study for G4 type coal. I don't know how much G4 coal is available in India. We are talking to use G13, G14, G12 coal. G4 coal may not be available more than 10% of that total coal available in India. So what is the use of making? What is the use of making a study for the G4? G4 is a very high quality coal. So that anyway going to run without problem. So that is not solving the India visions. Kulkarni Saab presentation, it was nice. And I think CO2 is still very high in the fluidized bed. Kulkarni Saab, what you are telling 27% of the CO2 coming out from the fluidized bed gasifier. And it is a moderate temperature gasifier, so it should be very less. Because there also the methanol cost will be very high. If I remember, somewhere in 2016, Balyan Sahab has presented for the methanol, making methanol in that seminar, gasification seminar. So that time, if I remember the figure correctly, they were telling if the coal comes at 900, then methanol will cost 27 rupees per liter. So
I think let's concentrate on questions, not on observations. Any more questions?
that's what I'm asking, sir. Because what is the cost of the methanol? What Thermes is telling that is very high. What is the economics? What is the cost they are expecting for that?
Yes.
For other two was only my observation. I don't have the questions.
Okay.
But for Kulkarni Saab, I will definitely ask the question because they are leading the research.
Would Mr. Kulkarni like to answer?
I think your question is on the CO2 content on the
CO2 content is okay, sir. Cost of the methanol. How are you looking for the cost of the methanol? What will be the coal cost and what methanol cost you are expecting?
That is where I think I presented one slide where I think I said it has to match the commercial grade methanol, and to achieve that commercial grade methanol, I think we need to contain the operating cost to a level of about 15 to 17 rupees, and with high ash coal, I'm saying. So that is possible.
Mr. Tiwari's question is, what would be the cost? The precise figure, or you don't have the precise figure, even approximate figure?
I mean, if you work out the cost today, it may be about 20% higher than the commercial cost. But we need to take into account the electricity price and then the coal price. I mean, these are the variables I think we need to understand.
Suppose you take the coal cost of 3,000 rupees per ton. What will be the cost? Because some idea has to be there so that you can post to the government that if you are not having the coal at this cost, methanol plants are not going to be viable. Because electricity is also coming from the coal only. So let us say 3,000 rupees per ton is the coal cost.
So I will put it this way: if the high ash coal is available at less than 2 rupees, then the methanol plants will be viable actually.
2 rupees per kilo.
2 rupees per kilo, yeah.
Okay.
Less than 2 rupees. Less than 2 rupees.
Less than 2 rupees, yeah.
So I hope Mr. Tiwari's question has been answered. Any more questions? I'll close the session with just a few observations. It's very good that so many companies in India are working simultaneously on this important aspect. I'd only suggest or request that underground coal gasification should also be given attention. Because you see, once it has been successful, it has been rejected But now the facts have emerged that it has not been rejected because of technical fault. It has been rejected because of the users or the developers' insistence on getting more than what the design was, what the plant was designed for.
Mr. Kumar, can we request Mr. Balyan to chair it, please, now?
Yeah, I just may make 1 minute. We are talking about green hydrogen. See, as the present situation stands, green hydrogen it come to the scene. But right now, why can't we take grey hydrogen where power plant capacity is available and it can be utilized? So this has been a good session, and I do hope that the issues which have been discussed will work on it further. Thank you, Mr. Balyan. I have taken your time, and I apologize.
Yeah, over to you, Mr. Balyan. Thank you, sir. Thank you. Thank you, Kumar sir, for moderating you very well. Thank you, Mr. Kumar. Thank you very much.
Thank you, Kumar sir. This was wonderful, very interesting and nice presentations. Amit, can I have the sharing rights for my small few slides and then?
Yes, sir. I have given you, sir.
Okay. So can you see my presentation?
Yes, sir. We are.
Okay. So first of all, thank you very much, SOCHM, for giving me an opportunity to be part of this very interesting webinar. And I must thank Mr. U. Kumar sir for a wonderful initial session where many of the important aspects have been discussed. And I think what emerging is from all the discussion is that we need to really put all our thoughts, all knowledge to really work out what is the best technology for different coals in India. Number two, what are the targets that we need to really achieve in terms of the products and their utilization point of view. And I think the other policy matters and all we are going to deal with in this session that may also be important from the point of view of really making coal gasification in India a successful venture. So just a few thoughts initially, which I would like to move ahead. In a preamble, I think just a few points on that we must really see the issue of coal, a very important aspect and a resource for energy. We need to be conscious of what's all happening worldwide. I mean, India cannot remain isolated when it comes to talking about energy sources. We are largely a importing country. We import more than 80% of oil and more than 50% of gas. And we are a large country. We have a diverse requirement. Our per capita energy consumption is low, which is bound to grow. So in that perspective, we have to see coal becomes very important. And this is an indigenous energy resource which is available. And some of the studies that have brought out is that while in other parts of the world, it may be a different scenario. But in this Asian part where India is dominating here, coal will still play an important role till 2050. Till 2050, in major parts of the world, the renewables and non-renewable, fossil and non-fossil would perhaps be achieved 50-50%, which is a very significant change from the energy transition point of view. But in India, the studies say that coal would still be a dominating energy source for India. And we see the production going up and may touch about 1 billion ton mark by 2024-25. So what do we do actually with such a good resource available? The only way is that use it by making coal as green as possible. And how do we do that? And that coal gasification therefore assumes a great significance when it comes to India using this domestic indigenous resource that is available. And in that perspective, we must also take note that a very ambitious target of utilizing 100 million ton coal for gasification has already been given to us. And we need to really be recognizing the things that are changing very fast when it comes to opportunity for coal gasification. As we say, that's a very promising way of using coal in a greener way when it comes to coal gasification. And it really gives us diversification opportunities going into different products. And we regard it, and I personally see that as a new business segment that is evolving in the country, and we need to really see to make it successful. We have in India now initial experience where companies have really invested into plants. They have also gone into problem solving, learning from their investments and technologies, and have come out of that also. So I think we have very significant good experience now, and I think we are all set that we need to really look at very differently now with the experience with us on that. We also see that the present and future coal gasifiers need to come under one umbrella so that we can make coal gasification as a viable, commercially viable and lucrative as far as country is concerned. I think in India, the industry has realized that only a collective and focused approach of all stakeholders in the coal sector will help, in particular this initiative, to move to higher level of performance and achieve what the ambitious target has been set by Honorable Prime Minister. Collective information sharing, brainstorming, some of the R&D work, advising government authorities on what would be appropriate for policy framework to make it more commercially viable and investment friendly. I think in that perspective, I must share and happy to share with all of you that a Coal Gasifiers Association has been formed in the country. It has been registered on the 3rd March 22 under the Societies Act in Delhi, and has already taken part in some of the initiatives actively. Like we had the webinar some time back on coal to hydrogen, also participated in the IME conference and exhibition in Kolkata, and this is the 3rd webinar that we are taking part here. So it's very, very heartening to see that there is an effort by the industry to come together to share all the knowledge and move ahead to make this segment of business more lucrative and attractive. We all know it offers this several advantages on that, and I think we all are aware of that. We need to really capitalize on the various opportunities that exist for coal gasification. When we look at the national perspective, I think it fits in so well with the national goals. One is the reducing our dependence on imports. It's unfortunate that India, with all that vast resources, still imports coal to about 250 million tons per annum. I think this is one area that we can really address while we pursue coal gasification and reduce our dependence on that. Also reduce perhaps dependence on our import of oil and gas as well. The second aspect is that the self-reliance. I think it helps us in what the other colleague also talked about, India being Atmanirbhar in many other this thing. Also in some of the value-added products would help us achieve this national target. And third, very importantly, where that no energy source now is examined for use without the linkage with the emissions. So I think this would also promote and fits into the national perspective what the government is pursuing. So I think from all point of view, it's a very important, suitable for India to pursue coal gasification. Indian government has very nicely recognized the potential and benefit of the coal gasification, and they've proposed 100 million ton of coal gasification by 2030. And this would perhaps bring in investments of over 4 trillion rupees. I think this is pretty good. We are also happy that many of these suggestions made by the industry through the forum of while we were formulating the Coal Gasifiers Association in India and made interactions with the government and all the policy makers, that they have included several suggestions of industry, of the association, in actually formulating the coal gasification mission. And we are very happy And we also see that there are certain follow-up actions that the government is taking, where the steering committee has been formed under the chairmanship of Dr. Saraswat and some of the members of all stakeholders, like important stakeholders like Ministry of Coal. And we also see some of the major player in the industry like Coal India is all set to implement 3 gasification plants at different places and are moving ahead with bringing other companies together for a very comprehensive implementation of coal gasification and uses of the products. There are, of course, several challenges which are coal related, and I'm sure my speakers in this panel would talk about. So there are challenges. Some have been pointed out, like which are coal related. Some of the challenges are environmental related, where we have large effluent coming out of the plants. How do you really address such an important thing? And we need to really be conscious of that. We have to somehow achieve the net zero emission. The target set by the Prime Minister for India is 2070. And I think this can only be achieved when we start right now on addressing the emissions aspect of that. Issues like carbon capture and all are so important for India. Ash content, so they are environment related issues. There are, of course, technology and project related issues which some of the speakers have talked about. How do you really customize the technology suiting to the Indian coals here? And also while projecting and implementing a project, targeting certain products which are having so much demand within the country, so that can be addressed, and we don't have to really look for again importing. So the technology and project related thing, and also the policy related. Here I would like to really see that as an association, Coal Gasifiers Association of India, we recognize this an opportunity of a new business venture in the country. We also feel that there is a need for a policy framework which facilitates coal gasification by way of coal allocation in the same way as it is done for the power sector. Also that the coal pricing should be as under regulated sector. That would be really very, very beneficial for taking off of this new venture. We also would like to see that coal gasification also has long-term linkages, and also that this particular sector is recognized as infrastructure sector. These are the issues that the Coal Gasifiers Association is pursuing, and we are now very actively involved, and we would like all the participants of this particular webinar also to please get in touch and become members of this association, so that we can collate all the issues and really take up forward with the government and other concerned authorities to see that a very favorable policy framework is developed for the country, for all the coal gasifiers in the country. We see a vision that collectively, I think we can make a difference there. We like to capture all the information, suggestions and all. We would like to present a white paper to the Ministry of Coal and Niti Aayog. We are preparing right now on this. We propose to hold periodic meetings, consultations, information sharing with all the industry players, and then with the authorities on this. We would certainly like to organize relevant topics, national seminar, workshops on technology issues, funding issues, which has come up very well and very important for this sector. And also, how do we companies, whether Indian or outside, collaborate for implementing projects? There's a lot of opportunity that will be coming up. So we see that CGI, the Coal Gasifiers Association, is all set to really work with all the stakeholders to address all the issues that are coming up in this sector, and look forward to facilitate them, to solve them in consultation with the government authorities. You can get in touch with the association, and we would like to really take forward all your issues, all your points forward on that. So they were my initial points, and I'm sure the panelists in my session would now take up in detail. So can I invite our first panelist, Shri Chiranjeev Patra, the General Manager, Clean Energy Department, CMPDI. Mr. Patra, are you there?
Yes, good afternoon. Can you hear me?
Yes, please. Yeah, please make your presentations. I would request, in the paucity of time, to be very precise and just make points rather than reading out the presentation. So maybe around 5 to 7 minutes, Mr. Patra.
Yes, I don't have any formal presentation. I would just like to say a few or couple of things regarding what Coal India is thinking right now.
Yeah, please go ahead. Yeah, sure.
Good afternoon, all the panelists. I am Chiranjeev Patra from Central Mine Planning and Design Institute Limited, which is a fully owned subsidiary of Coal India. And we are basically giving consultancy in all related fields to Coal India and other companies also. So recently, a cell has been created in CMPDI, which is the name of the cell is Clean Energy Division. And we are dealing the coal gasification projects that are being taken up by Coal India Limited. So basically, there are 4 to 5 coal gasification projects that Coal India intends to take up. First one was in Dankuni, DCC Dankuni. A tender was floated for production of methanol. The tender process is on. And there are subsequently, we are going to have 4 other projects. These projects would be implemented in one in Eastern Coalfields Limited, one in Southeastern Coalfield Limited. The third one is in Western Coalfield Limited, and the fourth one, we are yet to finalize the location of the fourth one. The first one, that is in Eastern Coalfield Limited, we have already floated a tender where we are searching for a BOO operator on coal gasification project, and the final product will be methanol. The next project that is in Southeastern Coalfields Limited, we have already floated a tender in a similar manner for having a BOO operator, and the final product there will be ammonia. And we are in the process of floating a third tender where WCL will be the implementing agency, Western Coalfield Limited near Nagpur, and the final product will be ammonium nitrate. And for the fourth one, we recently are in collaboration with BHEL, who has developed indigenous technology on fluidized bed technology. So we are in collaboration with BHEL so that we can take up a project in collaboration with them. And that may come up in Central Coalfields or MCL Mahanadi Coalfields. That we are yet to decide. So these are the projects that at the moment Coal India is taking up. But there are issues and there are concerns. One of the major issues that I would like to say is that as from the experience of Jindal Power Limited, who have a gasifier in their Angul plant, the consistent supply of coal from a particular mine. So they have faced problems, several problems for consistent supply, supply of consistent quality of coal rather. And for this purpose, we in Coal India have identified a particular mine for a particular project. So this issue that JSPL is facing, I don't think in CIL we will be facing that problem. Now, regarding the indigenous technology, whichever we have discussed by the previous panelist, that we need to have an indigenous technology for our low rank high ash coal. So till we reach a consensus about the technology that is to be adopted for our high ash coal, we are relying on foreign technologies, basically I would say for entrant bed technology. But for entrant bed technology, the problem or concern is it's a very high or capital intensive technology, and the licenses available in the world. As for the case of Dankuni coal complex, we could see that only one party was there for supplying that technology, but the cost of licensing is on the very higher end, I would say. So this is one of the main concerns. Now coming back to the other concerns is that we in Coal India started our journey regarding coal gasification, keeping in mind that our first product, final product would be methanol. And we thought that methanol will be used as a fuel in our transport industry. And it was thought that a policy will come in this regard that, as you know, the 20% methanol will be mixed with our gasoline so that we can use methanol in the transport industry, and our import of petroleum products will be reduced in that end. But till now, the policy has not come yet. So if we produce methanol, what will be our market? It's a fact that we are a net importer of methanol, but the use is very sporadic throughout India. So how will we set up a supply chain for retailers who sell methanol throughout the country? Then we thought that yes, another product will be maybe that ammonium nitrate, which we use as explosive in our own industry. So that's why we thought that why not change the product, and so we thought of projects in WCL where we have decided that ammonium nitrate will be our final product. And the next problem is that we thought that as in Coal India, we don't have expertise in operation of such plants. So the mode of engaging an operator is through BOO, build, own and operate, and the capital will be wrongly. So in that mode, what we face a challenge is that only one party is there throughout the world who is willing to work on a BOO basis. So in this front also, CIL is thinking whether to change our mode of operation or not. So these are the few points that I wanted to share with you regarding
Thank you,
our
Mr. Patra. Very relevant, I think. Yeah, I think it really calls for a successful venture that the ultimate products are put to proper use. And that's a basis for making it viable and attractive in this thing. So I think very rightly, and I am very happy to see that you have a variety of products that you are targeting there. And I'm sure the discussion that we have had in the ministry and with some authorities as the Coal Gasifiers Association, we have made emphasis on pursuing methanol policy. So that would be very helpful for coal gasification. So we are pursuing with that also. But you have rightly pointed out that we need to have some assurance, a guarantee offtake of methanol when such projects are being implemented. So thank you very much for this thing. May I now invite my next speaker, Dr. Chauhan, are you there?
Yes, sir. Yes. Yes, sir.
Yes, Mr. Chauhan, your floor is yours now for make your observations, please. Yeah. Thank you.
Thank you very much, sir. Good afternoon to all of you.
Can you come closer to microphone, please? Little more louder.
Is it okay now, sir?
Yeah, that's better. Yeah.
Yes. Kindly allow me to share.
Yeah. Okay.
Yes. Is it visible?
Yes. Yes. Please go ahead.
Yeah. Thank you. Yes, I think most of the aspects related to utilization of Indian coal for various value-added applications through gasification route have been covered by earlier speakers. I just want to highlight, though it is everybody is aware, most of the reserves are having highest content except ECL. Accordingly, with the thorough understanding as well as previous several activities and programs and brainstorming sessions with the different agencies of Government of India, Ministry of Coal, we have taken decisions to what should be the utilization pattern to utilize particular resource. Mainly when we talk about the ECL area, fortunately we have a certain amount of low ash containing coal. So some different policies there for this particular resource. But for other resources, because most of the remaining resources are having ash content beyond 35%, so some concern is there. So this is the main, we can say, important aspect related to Indian coal resource. When we talk about the suitable gasification technology for particular resource, again, set of characteristics which are very relevant to gasification selection or operation of gasification particular facility, we need to take into consideration. For Indian coal resources, mainly as we know, ash content is on higher side. Then other certain properties like ash fusion temperature or its nature, its composition, all these are also we need to take into consideration. We will not go into detail about these properties, but we can say some specific type of nature is there with Indian coal resource that specifically we need to concentrate. And on the basis of these characteristics, we need to take decisions. Several technologies are there. For coal gasification in under three different categories. Out of these, few are commercially matured or proven technologies. People are utilizing these technologies for in different countries. Even in India, we have few projects with developed or commercially proven technologies. But again, we can also exploit these technologies for certain reserves or even for hash containing reserves also. But in that case, some washing, blending will be needed. So again, economic feasibility and those aspects also we need to take into consideration. So parallelly, another thought is there for uh, suitable technology where directly without any pre-processing coal resource can be utilized. So these are the important aspects we need to take into consideration while selecting technology as well as identifying the particular resource for matching, we can say matching with the particular technology. So certain permutation combinations are definitely required for that. And with thorough brainstorming, Government of India under the leadership of Niti Aayog has targeted certain programs. Option one is definitely as mentioned by earlier speakers with mainly entrant flow technology, proven technology. And first targeted project is Dankuni Coal Complex project utilizing ECL coal, which is low ash coal. Another few projects are already Patra sir has given light on that also. Parallelly, development of indigenous, because why indigenous? Because again, under fluidized bed category, proven technologies are not available, or we can say tested technologies are not available. That's why development of indigenous technology under fluidized bed is taken up as a important option, as an option too. Already, few organizations have developed, including Simper, Thermax, BHEL, at pilot scale level. And now time has come to upscale these developments to demo scale, so that we can compare these developments with commercially available technologies and attractive option one can take forward to fulfill our requirements and the Government of India's programs also in the area of gasification. So in line with this particular Government of India's program, CSIR Simper is also pursuing the program in the area of gasification. We have very good facilities, including all the aspects related to gasification, right from characterization aspects, bench scale, pilot scale facilities to evaluate the performance, to develop the strategy or utilization pattern. Apart from these directly linked facilities, we have very good facility for supporting activities also, including pre-processing, crushing, screening, or if required, washing, and other supporting activities also in the area of coal. We have very systematic analytical hub for that, also training and skill development center, including all the aspects. And with this capability, Niti Aayog entrusted one important activity, gasification potential mapping. Jointly, Simper and CMPDA has completed this activity. We have covered 3 subsidiaries of Coal India, MCL, CCL, and ECL, with identified mines by CMPDA on the basis of available inventories as well as linking, non-linking status, and other strategic decisions. And we have developed thorough characterization matrix with all the characteristics, around 10 to 12 characteristics are there. We have developed matrix. On the basis of this particular matrix, we have suggested what should be the utilization pattern for per specific resource. What should be the strategy to selection of particular gasifier for particular specific resource. So entire this exercise we have completed. Definitely we need to extend this exercise for remaining resources also. This is needed before thinking any venturing for other resources, other subsidiaries also. So this is related to characterization part. Now coming to the gasifier development part, we have developed air-blown fluidized bed gasifier in 2009. We have tested coal resource from few subsidiaries again in the pilot scale facility also. And with air-blown gasification, CO hydrogen composition was attractive, though it is not suitable for applications like say methanol, fertilizer, DRI, but for thermal application for power generation, this is even air-blown is also good option. Then after getting confidence in the earlier development, we have upscaled this facility, and now it is oxy-blown fluidized bed gasifier installed in December 2020. We have tested high ash coal resource from MCL and CCL area. Now we have established operation with suitable operational philosophy. Syngas, which we have achieved through this facility, is quite attractive for value-added applications, including methanol or liquid fuel generation, or even for any downstream application. carbon conversion, syngas yield is also good, quite attractive. It is a pilot scale development, so certain aspects related to upscaling definitely we will address in the further developments, mainly related to the establishing the engineering components as well as emissions related, byproduct management related aspects, as well as
What is the scale, Chavan sir? What is the scale of this pilot?
Yes, sir. This one is a pilot scale having capacity 1.5 TPD coal feed rate.
Okay.
So now target is to develop. We are already in the process of development of downstream module also for syngas micro cleaning, conditioning, as well as syngas to methanol, as well as for other applications also, which are suitable, which we can conduct in the this particular facility apart from methanol. Now coming to the, because already we have completed development at pilot scale level. So what should be the pathway?
Another 2-3 minutes, Chavan sir, please. You have to wrap it
Yes,
up.
yes, yes. Just 2-3 slides, sir. So now target is to take forward this development at demo scale level. So what should be the pathway? Because to utilize any technology, we need to keep in mind it should have wide range of heat acceptability. Because certain concerns already people have raised in several forums, even in today's discussion by earlier speakers also. So these are the left side, we can say these are certain concern, important concern definitely we need to take into consideration. It should have wide range of acceptability, minimum pre-processing, because fine size handling related issues are there, byproduct emission related issues, as well as syngas quality. Simultaneously to handle any feedstock when we change, that's why the question important aspect comes in picture. There should be consistency in the feedstock. Otherwise, what happens in case of any chemical industry? Standard operating procedure is quite sufficient to operate the plant, but in case of phenomena like gasification, we need to develop feed specific operational philosophy every time. That's why consistent feed supply is essential. This particular aspect also we need to take into consideration, and thorough characterization is essential for developing operational philosophy as well as selection and development of technology also. These three important aspects are there which we need to take into consideration. Now coming to the what should be the next step. Yes, definitely understanding of fuel. Already Ministry of Coal has initiated activity related to Dankuni Coal Complex project, where entrant flow gasifier will be utilized. And now our target is to take forward the pilot scale development to demo scale with suitable operational philosophy, and simultaneously we need to take into consideration the poly generation also, because always cost is the primary factor to take any decision. So when we go for any single product facility, definitely it may not become economically attractive, because several side streams are there, including nitrogen during oxygen generation, as well as CO2 during conditioning of the syngas for methanol or any product. So we need to utilize all those streams. So it should be combination of fertilizer plant, power generation plant, and targeted product, so that we can take out maximum gain. We can take maximum output with minimum emissions. So poly generation should be taken into consideration, what we feel. So with these aspects, we are suggesting two combinations. Option one as a dedicated facility, including all the modules, right from pre-processing, gasification, micro cleaning, conditioning, methanol. So this demo facility, if we target, it should be strategic facility at some strategic location, where we can, even there should be possibility to include further developments, to retrofit further developments at each and every module, because since it is an indigenous development, so we need to take care. Though it is some capex intensive, but in long term way, it will be more beneficial. If capex related aspects are, if any, if we can consider as a concern, then directly we can go with the developed pilot scale gasifiers and install the demo facilities either at some readily available facilities like say GNFC, where already methanol generation and fertilizer plant is there. So one can install demo scale facility in the nearby area near GNFC, or either proposed plant at Dankuni Coal Complex. So indigenously developed plant can be retrofitted with these commercial facilities, and once we gain the confidence and prove the attractiveness, then we can take forward this indigenous development also. So this is all about our
Thank you,
view
Mr. Chavan.
with this.
That's a very good presentation, and I see you are proposing some very specific location for a specific plants that is based on your studies there.
Yes,
And a
sir.
good amount of work has been done in terms of potential mapping of the coals, So very good work done on this, and I'm sure this is going to help the coal gasification in a very significant way. Thank you very much for your presentation.
Thank you. Thank you very much, sir. Thank you.
Request my next panelist, Mr. Prabhakar, General Manager, BHEL. Mr. Prabhakar, you are there?
Yeah, I'm here, sir. Good afternoon. Can I just have the sharing rights? I have very few slides. We will just share it. I think obviously we are running out of time, so I'll be very brief. Yeah. Slide mode. I hope my presentation is visible, sir.
Yes. Go ahead, please.
Yeah. So good afternoon. I am Prabhakar, General Manager, Central Marketing Group, BHEL, New Delhi. So I will just brief about what we are doing in PFBG. We were early the pioneers, and we'll just run through these slides. Next slides, please. In fact, this has been already discussed by many panelists. This is the dichotomy what India is facing today. On one hand, we are the fifth largest producer of coal. We have so many billion tons of reserves. On the other hand, climate change is recommending a phase down of coal power, thermal this thing. And whereas we are a growing economy and our import dependence on energy is increasing. So all these points, that diversification of coal, that is the bottom line, for its sustainable use is inevitable. And I believe gasification is one of the best ways to diversify coal for going into sustainable use. Next slide. I think BHEL, just a brief overview, most of you will be aware of BHEL. We are one of the largest engineering companies in public sector in India, and we are into thermal power, and we were one of the pioneers in gasification and fluidized bed combustion technologies over the years, especially our BHEL Trichy unit. Next slide. Just to recap, this was our timeline journey in gasification. Very early, way back in 1980s, we had developed a moving bed gasifier, 150 TPD, for integration with the IGCC, integrated gas. That time, the focus was not on producing chemicals through gasification, but more on power generation. So the government of India had applauded us to do something in the IGCC. So we had first set up the 150 tons per day moving bed gasifier. But we faced a lot of issues like tar formation, low conversion efficiency. Then we set up a pilot 18 tons per day at our corporate R&D plant in Hyderabad, which was based on fluidized bed technology. And once we could get some good feedback from that, in 1997, we set up one of the largest gasifiers as of today in country, a 168 tons per day PFBG at Trichy, where we have a 6.3 megawatt combined cycle demonstration plant. And it had run for quite some time. And based on that, we were supposed to put up the first IGCC based power plant in India in Abgenco, 182 megawatt. But for some non-technical reasons, that could not happen, because as some earlier speakers also shared, that time the comparison was made with the supercritical and ultra supercritical per megawatt cost of generation. And the policymakers felt that IGCC need not come now. Wish it would have come now, it would have solved a lot of our problems, but that was it. And then we kept our research in that. And later on in 2000, we put up one more advanced pressurized fluidized facility, a small one, a test rig at IICAT campus in Molali in Hyderabad, which we had along with our corporate R&D. And we were doing this thing, next slide. And subsequently, we put our 168 tons per day plant at Trichy was air blown. Basically, it was generating syngas cleanup for running a gas turbine. But what we did in our Hyderabad, this thing, we developed the oxy-blown one. And subsequently, next slide. This is a view of plant at Trichy. Next one. Yeah. This is in brief, which I had already touched. Way back in 2002, we were supposed to develop a combined cycle IGCC plant, and we were ready with it. And what I want to highlight the point that the feasibility of scale up from 6 megawatt to 100 megawatt was established way back there. But the IGCC could not come up. Next one. So what we did recently is under the aegis of Niti Aayog, we got some grant from DST, just like what Thermax has done, and we developed our nation's first 0.25 TPD coal to methanol demo plant at corporate R&D. And this is fully functional plant, and this has established basically that without the help of foreign technology providers, we are able to demonstrate that we can get methanol from high ash Indian coal. So this was a watershed achievement, and it was inaugurated last September 2021, and the Minister of Heavy Industries dedicated it to the nation in Jan 22. Next slide. These are some of the snapshots of those plants where we have demonstrated our capability in this coal gasification.
This is still working. This plant is working.
Yeah, it is working, sir. And in fact,
performance?
It is, pardon me?
How is the performance?
Yeah, performance is quite nice. We are able to get 99% A grade purity methanol from 42% high ash coal, what we source from Singareni. So this at this scale, it is fully established.
And you use the power from where?
Pardon me?
Power you use for the plant is generated where?
No, the power is taken from the grid. This plant was set up by the side of our gasifier plant. Okay. And the syngas feed, what the snapshot you see is, this is the coal to methanol plant. The gasifier is by the side of that. And this we established all the modules, the cleanup module, the synthesizer module, and all these modules were established. We in-house designed it, and we manufactured it, got locally. And then we established, it took almost 3 years. We got this started in 2017, and somewhere in 2021, we could finally establish. In between, we were bogged down with some compressor issue, which we wanted to get from China, but finally we could manage it. And then this plant is very much working. It is a demo plant, it is working. And next slide. We are right now working, this is what we are immediately approaching. See, we are parallelly working on in-house developments of syngas to chemicals on a commercial basis. But to meet the immediate requirements, what Patra Saab also mentioned, we are working with Coal India for their central coal field for a 2,000 ton per day ammonium nitrate plant. For that, the gasification island, we are fully established. We have scaled up also. But for the time being, we'll be going on with commercial licenses, what we have on who are the world leaders in this area. But in the longer run, this is the mandate what government has given us for being the Atmanirbhar. We'll be working to, one is to scale up this methanol plant, and similarly try to develop this facility for generation of other chemicals like ammonia, hydrogen. So this is the way forward we are working. Next slide.
Good.
I think this summarizes whatever I have already told. I think in case any doubts, I am too happy to clarify. Thank you.
No, I'm just interested in knowing that your second point, for the experience is development and operation of a pilot 6.2 megawatt. What is it?
This is the IGCC, Integrated Gas Field Combined Plant, what we have in Trichy. So IGCC basically combines a steam turbine with a gas turbine. So the combined output is 6.2. But the highlight is the gas turbine is not run by the conventional natural gas. It is run by the syngas. That is the gas
That's what I wanted to know. Yeah, that's what I wanted to know. Okay.
Right.
Good. Thank you. Very interesting.
Thank you, sir.
Best to the BHEL and to Dr. Nalin Singhal. Please convey our best wishes and regards to him.
Sure. Thank you, sir.
Good progress and all the best for this thing. Thank you very much. We have now the last speaker of our session here, Mr. Varun Kumar, MD Dev Energy. Mr. Kumar, are you there? Mr. Kumar?
I'm here, sir.
Yeah, please, you have few minutes. Unfortunately, we are having a shortage of time now, but still, I would request you to use
Can I ask
presentation.
organizers to give me sharing rights?
Amit, can you please make him co-host? Yeah, okay.
So is the presentation visible, sir?
Yes, please go ahead, Mr. Varun.
Yeah, so I'll just take 5 minutes. Basically, what I want to highlight here is that there are two aspects to gasification. One is a very difficult aspect, which is using coal gas or syngas as a fuel, a feedstock for generation of other chemicals. And the second is, as some of my friends in the industry have pointed out already, is to use this gas to generate heat, right? Furnace applications. So now we as Dev Energy, we have been operating in this environment, is this market, this ecosystem since 2004. And I already have a installed base of more than 180 systems where we are generating coal gas to replace the expensive fuels like natural gas, LPG, furnace oil, and even PCI applications where we are using low ash imported coals like Russian and anthracite coals. So this aspect of gasification in the last few years, Niti Aayog and Dr. Saraswat and also Piyush ji from Coal India have been working on gasification relentlessly. And I'm glad, Ashok ji, that you have formed an association now. We've been orphans in the industry since last 16, 17 years. But this is being missed. You know why I say this is being missed? Because in terms of import substitution, probably we are doing much more than what can be done in next 10 years for the feedstock business, right? Because all the alumina plants, all the pellet plants, all the lead, all these plants are already, all the glass plants are already running on furnace oil and LPG, right? So my focus has been to provide this technology to industry for generation of heat, and this I have been doing in partnership with Yishan China. This is one of the largest fixed bed air-blown gasifier makers in the world, and this is another aspect I want to highlight. You see, as a group think, we are all shying away from China. In the last presentation also, BHEL is talking of world leaders. I would say they are not world leaders. They've just done few plants which can be counted on fingertips, and Chinese have done maybe 100 times more plants than all these people combined, right? So we are not, as a country, shying. We are not accepting Chinese licensors or technology providers or service providers into our fold, and probably missing on a very big opportunity. Now, what is our technology? It's fixed bed, updraft, two-stage gasification where VM is taken out separately, carbonized gas is taken out separately, and then we used 7 stages of cooling and cleaning, and we can generate a gas of 1400 kilocalorie and a cleanliness level of 40 mg. This is gas which is probably usable as fuel in almost all applications. Between us and our parent companies in China, we have around 45 different industry applications running perfectly well across the world. These are some of the plants we have done. I can develop plants which can use 100 tons of coals per day to 1,000 tons per coal per day. This Jindal Patratu plant is designed for around 900 tons of coal per day. It can use any grade of bituminous coal, and any grade, I mean, I have gasifiers running on almost G14 grade coal, up to G3 coals. And current and last 18 years, the saving versus furnace oil per calorie, 1,000 calorie, if you do all the mathematics of total net cost, has been in the range of 40 to 60%. So I'm writing 50% as an average number. So these are the sizes of the plants we can do. Some of the largest brands of tiles, some of the largest brands of pellet are working on our gasifiers. 24/7, 365, no backup fuel, nothing, right? So what are the opportunities? I think most of these opportunities have already been highlighted. One I want to highlight is low SOx emissions in the furnaces, because the system will keep the sulfur with it, and the gas will go out without sulfur. Whereas all other fuels, furnace oil, anthracite coal, they all have high sulfur, right? And the second point I want to highlight is about reliable and proven. There is no experimentation in this fuel gasification industry, right? So it's reliable, it's doable. What are the challenges? Almost all challenges we have been facing from last 17 years. One of them is the recognition of this activity or this business as a nation building technology, right? And what Mr. Ashok had already pointed out in his presentation is the availability and the linkage of coal, right? And one point, sir, we need to take up as a group is the pre-approval of technologies from the Central Pollution Control Board, State Pollution Control Board, and NGT. This is the primary thing for our technology, is that the user need to have a pre-approved technology so that they don't need to think of this technology as a risk. And clear guidelines of usage of ash and tar. It's fuzzy. If each state pollution control board comes up with their own ideas of this, and the customer is bogged down by the unknowns. Another aspect we can work as a group is on bank finance interest rates, or some sort of government incentive on the interest rate. I'm not saying capital subsidy, because these are payback plants. I'm only saying some sort of incentive in terms of interest. Why? Because then the financiers know, the banks know that this is a bankable project, right? Okay. And last point is ease of technology of technology transfer from China. The more and more curbs of this should not be done from China, or this kind of aspects, are putting doubts in the mind of investors that whether a Chinese originated technology should be implemented or not. As Roger had pointed out in his presentation, Case Group has done around 80% indigenization. Same way, we have factories here in GAV, and almost 75% of indigenization has been done. But still, the core technology remains with the Chinese. You don't need to hold their hands in order to manage the unknowns. I'm not saying manufacturing, I'm saying the technology unknowns, right? Because they have a larger format of experience as compared to us. Some of our projects, I just want to highlight the photos so that people understand that these are done and they're working projects. This is Jindal steel designed for 80,000 Nm³ per hour, 10 units of 3.6. This is a very difficult project. This is Hindustan HSIL AGI glass. So this is probably the world, outside China, this is world's first glass furnace on gasifier. This is a pellet plant running on gasifier. This is another pellet plant running on gasifier. This is a straight grid pellet plant running on gasifier. These are tile plants running on gasifier. The gas quality requirement are very, very stringent, because a slight amount of tar, dust, or sulfur will spoil the quality of the tiles. Thank you.
Thank you very much, Varunji. I think very valid points you made, and I think one of the important points that my takeaway from this thing is how do you really make a suitable framework for funding of such projects? I think there are different options that are available, and the government, I'm sure, must be looking at to really support such projects. One way could be that viability gap funding, which is done for several projects which are in the sort of demonstrating a new development there. So that could be one.
Ashokji, Ashokji, in terms of fuel gasifiers, there is no need for viability funding because these plants pay back in less than a year.
Yeah, I mean, it depends upon really the payback and many other this thing, but the initial investment.
Yeah, the money need to come from the banks. So somebody,
so there are other options
we
as
need
well.
We need to put some framework.
So I think this is an important thing that we are taking up as an association also for helping investors come together to move ahead on this. But it's a very important point, and I take note of your this thing. Number two, the China, of course, has much more experience, no doubt about, in terms of coal exploration, coal usage and gasification as such. I know more than 15 years back, even our L&T had designed coal gasifiers for them. Initial gasifiers technology had gone from India there, you know, when they had no such experience. But then over the last 15, 20 years, they have moved ahead dramatically on that. So no doubt about they have more experience. And I'm sure at some point in time, the exchange of technology and access to that technology may be perhaps available, depends upon, of course, several other national issues that need to be addressed on that. But thank you very much for your presentation. So just to summarize this session, I'd like to first thank all the wonderful panelists. They have brought in different perspective and a very, very important thing, you know, starting from our Mr. Patra there from CMPDIL. They've done wonderful work there. They're good 4 projects that they are lining up, and I'm sure these 4 projects would really demonstrate many aspects of coal gasifications, and they have done wonderfully well work on that. Mr. Chavan has shown the capabilities of the lab there, the institute there. They have developed the entire report on the mapping of the coals as also on that, and are really helping on moving ahead. Mr. Prabhakar from BHEL have shown the capability that BHEL has developed over a period of time. I'm sure they would be one of the major partners now when it comes to engineering and construction work there. And Mr. Varun, on that, your own two-phase stage gasification is very interesting on that, and I think very valid points on that. I think over a period of time, we really see all aspects, whether technology, knowledge, base, experience over the within the country has developed, and as a very good sign on this. I would convey my thanks to all the speakers there. We don't have much time, but if there is any question, 1 or 2 questions we can take up. Anybody who has any question, please?
Sir, one small question with Mr. Prabhakar. This methanol plant, have we developed the catalyst also by BHEL only for methanol synthesis?
Yes, what in the demo plant, we didn't develop the catalyst ourselves, but we used a commercial catalyst with our technology. We whatever shift reactor we made, for that the compatible catalyst, we sourced it from the market.
No, methanol synthesis also, because catalyst is one of the very important things.
Correct.
That we have developed in India, or it is from outside, that's all.
I need to check back. I can get back to you on this specifically whether it is so.
Some of the licensors actually make a lot of money only on catalysts actually.
Yes, because catalyst is the only item which you have to change every 2 years, 3 years, and that is a continuous operating cost.
Precisely, sir. That is why Dr. Saraswat of Niti Aayog is prodding us to develop it, scale it up, so that we can come out of this catalyst from what these technologies provide. That is one of the reasons the government of India is.
Just I wanted to check, Sir Prabhakar, sir, because earlier PDIL was developing that shift converter catalyst, but now I think they also stopped. So,
any other questions? If there is no,
permit one small question to Varun. Varun told that all the sulfur is held in the process itself, nothing goes out. I did not understand that point, how that sulfur is held in the process itself. You're burning the coal and using the gas in the furnace. Why sulfur is not going to the environment? How is it stopping that?
So Varun, are you there to answer this?
Sir, I lost the communication. Can sir repeat his question?
Yeah, Varun, you told that sulfur is held in the process itself. It doesn't go to the atmosphere. How it is possible?
So
Because you don't clean the gas.
Tiwari, come on, you cannot ask this question. You are the expert, India's premier expert.
Oh no, I expect
I
that
think
we are
it's more
recovering
like
yes,
like a
sulfur.
quiz
Your
from
process,
teacher,
when you are
right?
burning, why it's not going?
More
Sometimes
like
I need to understand.
no, it's desulfurization, simple NaOH wash.
Yeah.
Okay.
Okay.
And
That's fine. Desulfurization, you say, then okay, you said it's
well,
failed in the
you
system, so
are
that's what I
running the
thought
biggest
where it's going.
running the biggest plant in India. I think it's more like a quiz question. Thank you.
No, only I wanted to understand the sentence, Varun. Desulfurization, anyway, okay, that's fine.
Thank you, sir. Thank you.
So thank you very much, all the panelists here at the end. Thank you very much, Upal Saab, Kumar Saab, for your first session. Was very good, very interesting. And I must thank once again SOCHM for a very nice, wonderful webinar on such an interesting topic, such an important topic for that. And our best wishes from the Coal Gasifiers Association to all the participants here and to SOCHM. Back to you, Amit, to you.
Yes, sir. Thank you all speakers for sparing their valuable time.
Thank you. Thank you very much.
Thank you, sir. Thank you, sir.
Thank you very much. Thank you. Thank you very much.
Bye.